Hello, friends! Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm your host today. My name is Whitney Lee. I'm a CNCF ambassador and I'm a developer advocate at VMware Tanzu. Each week, we will bring a new set of presenters to showcase how to work with cloud native technologies. We will build things, we will break things, and we'll answer all of your questions. This week, I have with me Jim Bagwadia here to talk with us about cloud native secured policy as code with Kyverno. It's more than just security. So this is an official live stream of the CNCF, and as such, it's subject to the CNCF Code of Conduct. So all that means is please be nice. Please be nice to other folks in the chat and to Jim and to me. So friends who are joining us live, please do say hello in chat and say where you're visiting from. I love that this is a global experience for all of us. And if you have any questions today, please do ask them as we're presenting. We're hoping today's presentation feels a lot more like a conversation than just Jim telling us how things are. So with that, I'm going to hand it over to Jim Bagwadia to kick off today's presentation. Tell us about yourself, please, Jim.
Thank you, Whitney. Thanks for having me, and thanks everybody for joining. So I'm Jim Bagwadia, co-founder, CEO at Nirmata. Also a maintainer at Kyverno, and we'll talk a little bit more about the Kyverno project and how it fits in and what it does for policy as code. I also co-chair
Awesome.
in the policy working group within the CNCF. So that's one of the working groups which focuses on everything policy related.
Amazing. I'm going to bring up your screen. Cool.
Yeah, so maybe to kick things off, I think it's always interesting to start with, the basics, right? So, and with every domain, the context changes a little bit. So, what exactly are policies for Kubernetes, right? And it's interesting because policies could mean a lot of things or could apply to a lot of different layers within any system. And of course, we all know policies from the real world. But a while ago, within the policy working group itself, we kind of stepped back and said, look, we need to better define this and clarify what do policies mean? Why do they matter within Kubernetes? And we came up with this brief definition, right? So, and of course, this was reviewed by other folks in the community, and this page has gone through a few edits. But here, one of the things it says is that policies are configurations, so it's part of configuration management that manage other configurations or behaviors. And in Kubernetes itself, there's several different ways of applying policies, and of course, there's others outside of Kubernetes. So within Kubernetes, there's things like API objects, which can act as a policy. So again, a configuration that manages some other configuration, like an or behavior, like a network policy. Or you can apply some policy through admission controls. Admission controllers can be built into the API server, can also be run as dynamic admission controllers, which is what projects like Kyverno and OPA Gatekeeper do. And you could do things like you could apply now custom policies to validating admission policy constructs, which just went GA in Kubernetes 130, right? So although this is fairly brief and maybe still a little bit meta, I like this definition of policy. I'm curious to hear your thoughts on it too.
I so one thing that makes Kubernetes like so popular is that it's highly extensible. It's highly customizable for exactly what you want. So kind of what I think of policies as like organization specific rules of things, actions that are or are not allowed to happen in your cluster. Do you think does that jive with your definition too?
Yes, except I think it's a bit more than that. That's a great
Uh,
starting point, right? Because yes, you want to describe what's allowed and what's not allowed.
uh-huh.
But you also want to impact things, especially for systems like Kubernetes, where changes happen, quite dynamically. There might be different roles, different teams using the same clusters. You want to also, manage in a declarative fashion how things change. right? So
Oh,
it's almost like you're describing a little bit of the future. You're saying, when a namespace is created, I want a default deny network policy, right? So you're not just allowing or denying, but you're declaring in some ways how you would like the system to behave when certain things happen, right? And that's the behavioral aspect of it.
okay. I see what you mean. So the word rules kind of implies like you're allowed or you're not allowed, like yes or no. And what you're trying to encompass is that maybe something will be changed as part of following a policy.
Yes, and again, what we're seeing in cloud native systems, which perhaps, 10, 15 years ago, for those of us who were doing IT back then, it was like, well, things were fairly static, right? You could lay down a policy, you could even write it in a document somewhere, and you followed that when you made a change. These days, changes come, from so many places. We're doing things like CI/CD with GitOps, where there's, things constantly changing. So
Yeah.
in that, these type of systems, of course, we need more digital policies which can sort of be applied when a certain trigger, when some things happen in the system, right? So when a user does a specific action or something else happens, or if you just want to clean up periodically, all of those can be forms of policies to manage other configurations and other entities or behaviors.
I have a question about Kyverno. So we're talking about policy generally. So policy can be like you showed before, like a limit range objects, like resource quotas. It could be like network related, what's allowed to go over the network. It could be like runtime related, like what's allowed to happen in the kernel. What's how does where does Kyverno sit in terms of what kind of policy it's making and managing or helping the user create and manage?
Great question, right? So Kyverno is a dynamic admission controller. So it
What
fits
does
in.
what does all like and what I have questions.
Yeah, go
So when
ahead.
I was first learning about it, first of all, the term admission controller was confusing for me because controller, every other context I'd heard of with a controller, it was bringing a desired state in sync with the current state, with actual state. And so an admission controller is different, though. It doesn't do that. Or maybe it does as part of it. So will you first explain what it means to be an admission controller?
Yes. So in Kubernetes, within the API server itself, there's several, things you can configure, which are known
Mm-hmm.
as admission controllers, in just within the API server, right? And these are things
Uh-huh.
like, let's say, always pull images is a great example, right? This does mutation as well as validation. So if you want to make sure that whenever a pod, and again, you're declaring something to say when there's a new pod, I want to force image pull to be always, regardless of what's specified in a pod definition that the user provides. So this
Okay.
is a simple behavior that you're describing as a policy, and the API server is capable of, you just, by turning this on and off through flags, you can control this behavior.
Mm-hmm.
So in this case, there, you don't need Kyverno, you don't need any other tool to apply policies like these, because these are admission controls which happen inside the API server itself. Um,
Okay.
and just to kind of go a little bit deeper into that, this from the Kyverno docs, what this shows is anytime there's a change in Kubernetes, right? So this is in the ITSM world, this is called change management, but now with our API driven world, these things happen, quite again dynamically and frequently. Anytime there's a change in the system, that change goes through the API server. It goes through authentication, authorization, and then it goes through a phase called admission controls, which are these three boxes: mutating admission, validation, schema validation, which the API server performs, and then validating admission. And in these three phases, you have built-in admission controllers, like what we were just looking at, for always pull images. And you could have external admission controllers, which are running as a job deployment or some other task with or process within your cluster, which can intercept that request and either allow or deny it or trigger other operations based on that request.
That's very helpful. So the thing that's being controlled is like some you're creating some sort of control over admission over what you're allowing to happen as part of getting into the cluster in the first place. But it could be validating and it could be mutating. So it could be just yes or no, like we talked about before, or it could change something altogether.
Yes.
That's so. What does the dynamic part mean when you say it's a
Dy-
dynamic admission to controller?
yes. So the reference here to dynamic is, I guess, contrary to built-in, which is just means that
Okay,
it's running in the API server. Dynamic admission controls means it's a separate process, like you're installing Kyverno as a deployment or a set of deployments within
got
your
it.
cluster. And this could be, by the way, I mean, it doesn't have to be always in your cluster, which typically it is because it has to be fast and low latency. Could be some external call that you're doing to check the API requests.
Okay. I have one more question. Are these questions good, or am I pulling you off track
No,
of
no,
what you wanted to say?
they're great. Please go ahead.
What's the difference between an admission controller and a policy engine?
Yeah, so admission controls is what we were just discussing in
Uh,
Kubernetes, right? It's this
yes.
process of either mutating or validating an API request, the payload for your API request. Policy engines are maybe a classification of admission controllers
Okay.
where they are applying some other declarative, policies to control your configurations or behaviors during this admission control process, right? So Kyverno, for example, or other policy engines can also allow or deny, but Kyverno goes a little bit further and can also trigger other operations like generation of configurations or like if you want to, of course, create reports, things like that within your cluster, you can also do that with Kyverno policies, which are acting again. It's plugging in into this admission control subsystem, but it's applying policies which you are also configuring as Kubernetes resources during admission control, which makes it a policy engine.
So, so admission controllers are policy engines with like that are specific to do Kubernetes specific things. So all admission controllers are policy engines, but not all policy engines are admission controllers.
That's correct, right? So you could
Okay.
run a policy engine which does not respond to admission controls at all. Maybe it's triggered by events. Maybe it does other, background work. Perfectly fine, right? But
Mm-hmm.
Kyverno or like projects like OPA Gatekeeper and others, they will be triggered. So their input is not like an API request from an external system, but it's more an API request coming within Kubernetes from the control plane anytime the user is requesting something. So in some ways they become part of your control plane subsystem itself, right? An extension of the API server.
So if we already have built into Kubernetes, like the validating admission policy now object, and we also have limit ranges and like ways to control the amount of resources we're using. We have ways to control network. Why do we need Kyverno? Yeah.
Yeah, so several reasons, right? And we'll see some of these as we dive into the demo, etc. So Kyverno is not just about, so basic validation checks which apply to a single API request. Moving forward, you can do them through validating admission policies. There's also proposals being discussed for mutating admission policies. So it's all goodness to make this as, built in as possible, right? Because then you're reducing the extra latency for calling Kyverno, applying policies, and getting the response back, which is usually very quick. But it's just one extra call that you're now, and pushing into the API server that logic. So you're basically programming the API server to perform that logic. And by the way, Kyverno as well as other projects now can start, managing validating admission policies too. So you could write a
Nice.
Kyverno policy to create a validating admission policy, which will program the API server to do certain logic. But there's a lot more to policy management than just enforcement, right? First of all, when we talk about, and this is a great lead in into policy as code, because you really want to test your policies, you want to, see policy results, you want to manage policy exceptions, and projects like Kyverno do all of this. And then because Kyverno is focused on Kubernetes, it also manages validating admission policies. And in the future, if there's mutating admission policies, that is taken care of, right? There's
Okay.
also policies which you cannot just apply in the API server. So if you need to look up some other object, right? Like
Mm,
when you like if you're configuring a load balancer service, but you want to restrict every tenant in your cluster to have a single load balancer service per namespace. That's a very fair policy because of costs and billing and things like that. So policies like that cannot run as validating admission policies. Other checks which also require external data, you cannot like look up a config map, you cannot do things like that. So
mm.
anything which requires more than a single object, you cannot run in the API server, and you will need a dynamic admission controller like Kyverno to apply those. And then generate policies, just those aren't supported in there, and there's several good use cases, like again the classic example for using that and then dynamically creating configurations is like triggers, like when a new workload is deployed, you want secure defaults for it. Or if
Mm.
you're creating a namespace, you want to create your network policy for that namespace by default, a quota for that namespace, and even things like roles and role bindings for that namespace by default. So all of that cannot be done in the API server, and you still need policy engines for that.
Excellent. Thank you.
Sure. Yeah, so maybe going into policy as code, right? So with
Ah, yes.
policies, there's a definition for those of us who I mean, if you haven't seen this page, definitely it's worth reading through, and please provide feedback on how we can improve this. But it's interesting if you look at policy as code, it's sort of all over, right? And it's just Google Kubernetes policy as code, and it shows. So there's a link from AWS which is talking about this policy as code solutions. But it's interesting to think about what exactly does policy as code mean. It doesn't mean that you have to write all your policies now in Java or Python or Go, or but it does mean that you should apply the same type of best practices that you would manage software with to policy artifacts as well, right? So, like, let's say if you're using, GitOps to deploy Kubernetes resources with things like policy as code, you would expect to be using those same tools to be able to also, manage your policy resources across your clusters. If you're using Visual Studio Code to write your policies, there's no reason, or write your software, you should be able to use the same type of systems again. So applying all the best practices that, and maybe some not so best practices for software development to policy resources is really the way I think of policy as code. And we'll see again as we dive into some examples and demos of what that could look like.
You've you've mentioned a couple times with the last question and now talking about policy of code, testing policy. And that seems really important because policy is like really powerful. But with great power comes great responsibility. Like you could really break some stuff if you put a bad policy into your cluster. So the testability, it seems really important.
Yeah, that's a great point. And I'll actually pull up a repo of Kyverno policies. So if you go to the Kyverno website, there's this, library of policies. It's ever growing. Right now we have about 320 28, it says, yeah. So several different policy examples, but all of these policies are managed in a Git repo behind the scenes. So this is the Git repo where the community will manage policies. So if you go into one of these, and I'll just take let's go into Istio policies as an example, right? So in this, by the way, to your earlier point, some folks may be running Istio, others may be running Linkerd, others may be running Cilium. So every Kubernetes cluster might require different policies based on what you're running,
Mm-hmm.
and it's not uncommon for large enterprises or organizations. You might have all of the above, right? So you really need to kind of understand how you want to apply these policies. So one thing I wanted to show you in this is with Kyverno itself, we came up with a new project called Kyverno Chainsaw, which is a declarative way to manage or test things in Kubernetes clusters. So what this is doing is this is an example of how you can write, a test case where it's running different steps and then asserting for different behaviors within your cluster. And the whole reason why the Kyverno maintainers, we went down this path is looking at existing tools for testing policy behaviors. They just weren't, on the level of what we required. So, we figured why not take some of the goodness in Kyberno itself and the declarative nature of it and apply that to creating the sub project called Kyberno Chainsaw, which is one way you can test now Kyberno policies. So this step, this is what it's doing is, so first of all, this is within a larger test case. And let's say here, it's taking certain actions. And as step one, it's running this, it's applying this file. And then it's going to check and make sure that the state is what you desire or what you expect. So if you go back to this assert one, what it's checking is it's a fragment here, which is saying the cluster policy need to call enforce strict MTLS needs to be in status true. So that's how you would now, compose your test cases and run this again. And we run this as CI jobs. So you can really check and make sure your policy behaviors are correct before you even, accept that PR into your repo. So that's one way of doing testing.
Cool.
Kyverno also has another solution, which is more for like a unit test. And I'll show, like, if we go to pod security and let's go to restricted, and we'll pull up one of these. So this Kyverno test is more at a unit test level where it will run through the Kyverno CLI. It will apply a particular policy and check for the results. And you could check for positive as well as negative outcomes by declaring again which resources you are going to apply the policy to and whether you expect a pass or fail, right? So these are the outcomes you kind of do. So two ways, two levels of tests really, and both are valid. One is more a unit test level. One other is an end-to-end test you would actually run against a cluster.
Cool.
So yeah, lots of interesting things there. So hopefully, and that shows again if you're managing the life cycle of policies, more than just enforcement of policies within your cluster, you want to be able to test policies, deploy policies, and by the way, it's also quite popular to apply the same policy now within your pipelines as well, right? So with
Mm.
Kyverno, not only so you can take a validating admission policy and apply that in your CI pipeline with Kyverno and check for certain outcomes or behaviors again
That's
before that's even deployed.
that's what I was going to say. That's so smart. You're not waiting until it's actually getting deployed. You can find out beforehand.
Yep. Yeah, so lots of interesting things there, but maybe switching topics a little bit, I wanted to, dive into a demo I prepared, which is showing how policies tie into platforms and platform engineering, right? And there's several reasons why, we see a lot of organizations building internal platforms with Kubernetes. And this is showing one use case where if you want to allow some self-service, how policies would apply and what they would allow you to do.
Cool.
So here, just to kind of show the setup, right? And we can share the links to this repo later. I'm going to use Argo CD as my GitOps tooling. And right now, I don't have, I just have my local cluster register. But what I want to do here is I'm going to run another cluster or register another cluster, which we're going to use as a shared cluster for our, let's say our development team to be able to deploy their applications and use, right? So the first thing I want to do is if I kind of look at, I already have a cluster created. So if I do kind clusters, I have an Argo CD cluster and I have the shared cluster which we'll use. So with the Argo CD CLI, what I want to do is add this shared cluster. And that itself, just by this trigger of adding a cluster, I have a policy configured on my Argo CD cluster that's actually going to trigger some behaviors, right? Because the first thing I want to do is when I add this cluster, I want to start listening for requests from my teams, my developers, to be able to deploy their applications. So if I go back to the Argo CD console now, um, I see that some few things showed up, right, just by registering this cluster. And the reason why that happened is again because I have a policy in place which was triggered by that creation of the secret which Argo CD manages internally. And when that secret got created, it went ahead and created a one like this particular Argo CD application or an application set, which triggered an application to be watching this Git repo for self-service requests. I also had, if I go look in my command line, I had a few application sets installed, which when I again that cluster got registered, it created Kyverno policies for that cluster. It also installed Kyverno on that cluster itself. So already my cluster now has admission controls and some safeguards around what can be done and cannot be done before any again application or other things happen to that cluster, right?
Yeah, I have a quick question and comment. We have a question from the guest, which is really just, I think, maybe a synopsis of what exactly you're making. Like, I understand that you're demoing what how to put guardrails on self-service actions, like you would need to do if you're building a platform. But can you be a little more specific about, because I guess like right now when you're talking about making a cluster,
Mhm.
are who's the persona making this cluster? Probably maybe an ops person is making a cluster that eventually developers are going to use for self-service.
Yes. So the
Okay.
idea is, as a platform team, as an ops team, you want to allow different teams to request and manage their own applications, but you want to put the right guardrails and the right behaviors in place where one team is not impacting the other, right? So
Mm-hmm.
again, with multi-tenancy or with other constructs, if somebody deploys an application which is misbehaving or consuming too many resources, things like that can easily impact other applications, right? So these type of things in a shared environment, you want to make sure that you have the right guardrails in place, you're allowing self-service, but with the right security checks and other things in place. Um,
What I like about what you're showing is eventually we'll get to the guardrails for developers, but right now it feels like you're showing here platform engineers making their own lives easier because these sorts of policies already need to exist. And so now they've automated how that can be made when infrastructure needs to expand.
that's correct, right? So the whole cloud native mantra is automate everything, right?
Mhm.
Or you first codify, you automate, and then collaborate, right, on different things. So I think, yeah, the step here. So because we have policy as code, we have other declarative artifacts and systems like Kyverno and Argo CD. just work really well together to automate those end-to-end workflows.
We have another question from the chat. So, what exactly is this policy detecting?
Yeah, so let's actually look at it, right? So, what the policy did was it was watching a secret get created. So the way Argo CD works is when you register a cluster, it creates a secret, and once that secret was created, it decoded that because secrets are stored in base 64, and then it internally what it did is there's two resources that it creates based on that trigger. Here it created an application set which is going to be or actually this is an application which runs on your Argo CD cluster but watches a Git repo, in this case this particular URL, for new requests from your dev teams or others, right? So this is the application that got created. And going back to the Argo CD UI, here's what we see, right? So this is the app which is just watching some Git repo, could be any Git repo where you want your developers to go ahead and create their applications. The other thing that it did underneath the scenes is also created a config map which has the address of this, and I'll explain why as we proceed with the demo in a minute. Why that is required, because in my system, thinking about how I wanted the platform to work, I want to cut out all the boilerplate for developers. I want them to, just have a very simple way to request applications. And to do that, I don't want them to know the address of the cluster or have to remember that, things like that, right? So it created a config map underneath. So if we go back to and look at, let's look at the Kyverno namespace. So this shared clusters config map, it registered the new cluster that we have with its address in here, right? And we're going to look this up in a policy that we'll just apply in a second. So this was just a setup step. We haven't really created any applications. The next thing I'm going to do is just go
Can
ahead.
I just have a quick comment. When I think of policy,
Mhm.
I think of more, of course, like the validation we talked about, or even mutation. I don't think I really thought about the automation or like the creation of resources, how it
Right.
could be such a big part of what's happening. So that's what's hitting for me right now is how powerful it is to be able to create resources.
Yes, and to
Yeah.
do that dynamically, so you're
Mm-hmm.
kind of, again, going back to the definition of policies are just configurations which manage other configurations, right? So, and managing configurations could be creation, could be deletion, could be cleanup, or even mutation of existing resources, right? So all of this is well within the scope of what policy management is. It's not
Yeah.
just about enforcement or security, and it's really the way I like to think about it is, why can't we just automate security using policies? So security is great if you can enforce it, but it's even better if you can trigger fine-grained configurations on the fly and remove, the I guess misconfigurations from the picture as much as
Yeah.
possible.
But remove the toil and the human error,
That's right.
both. Yeah.
Yes. So the next thing I wanted to do, just continuing with the demo here, is let's say now I want to request my own namespace or my own application to run on this shared cluster, right? So we have an Argo CD cluster, we have a shared cluster, we have an application which is watching a Git repo and saying anytime there's a change to this Git repo, I'm going to now deploy it onto this shared cluster. So here, all it's doing is it's looking at, what we're saying is, I want to create an instance. So what we've done is for developers to trigger their own applications, they would just create in Argo CD, you have apps and app sets. So here I'm creating an application. It's going to be called shared test. And all it's doing is if I go and look at this repository, I just have, in this repository, of the like the demo that we have. Here, actually, let's go back to sample apps, because what we want to look at is just an empty namespace with a quota, right? So all we're doing is we're requesting a namespace with particular quota configurations, and this can be customized, right? So I can override that in my request and say, hey, I want 4 gigs of memory instead of two, and somebody can approve this PR, right? So for the demo here, I'm not going to go through approvals or anything, but if I just look at my Git repo here, and here I'm using the same Git repo, but in of course, if you have a production environment, you'll be using a separate uh, Git repo for this. So let's say if I want to say request namespace, um, and I'm going to commit that, and let's push this, right? Um, so this would be just a change, or it could go through PR approvals, other things. But now that request has gone and it got pushed into my Git repo, which is being watched by this Argo CD application. So if we refresh that, what we expect to see is it automatically created now the shared test application on my Argo CD cluster, which in turn will then create a deployment onto my shared cluster, which is just an empty namespace with a quota, right? So, and what it also did internally is because when I made the request, going back to this, so by the way, this is an incomplete fragment of Argo CD application. And I have another policy which completes that with all the defaults for my platform. So here, like all the boilerplate about how I want to prune applications, how I want to clean up namespaces. I don't need my developers to be concerned with all of this, right? So all they're doing is saying, hey, deploy something from this Git repo into this shared environment, right? And I'm just going to give you the YAMLs I want to deploy, and then you can either allow or deny that based, on again the policies we have configured. In this case, it was allowed. So if we go back and kind of now switch to our, um, I'll go to the shared cluster. I was on the management cluster before. So if I go here and I do, you know, get namespaces, I should see a test namespace which just got deployed, and that has nothing except a quota. But underneath the covers, what because I have policies configured here, again, we're generating resources. So if I go look at this test namespace and say get network policy, um, it has a default deny network policy already in it, right? So it's secure. And if I try to now, let's say, run in this test namespace, so by the way, one other small detail I should have pointed out, I put in an owner label over here. And this is a user on my system that's already configured on the shared cluster. So right now, if I do, let's say, get namespace test, and I do this as another user. So I have two users, Ned and Nancy. They're both namespace admins, so they can both look at namespaces. So Nancy is not allowed to use this because Ned created that. But if I do this as Ned, I can see what's in here. I can kind of look inside the namespace because I have full rights permissions for that namespace. And all of this again got triggered by policies I have configured in my system itself.
Cool.
Now, going a little bit further, if I do here, like let's say in my namespace test, if I want to create, let's say I want to run an image, and I'm going to do that as Ned, right? So Ned has permissions into this namespace, but I'm running just some arbitrary image. Immediately it gets blocked because that image is not secure, doesn't have the right, default, or the pod security context doesn't have resource quotas, things like that. So based on my policies that I configured, that image gets, so if I look in this cluster, which is my test cluster, um, and let's CPOL is just short for policies. These are all the policies that automatically got deployed when we registered that cluster, right? So that's why
I,
Ned, go ahead.
I have a question. If I'm new to Kyverno and maybe new to policy or Kubernetes policy altogether, how would I begin to know what kind of policies are recommended for my cluster? Like that seems like an overwhelming amount of stuff right there. Yeah.
There can be a lot, but starting with basics like pod security. So every workload in Kubernetes runs as pods, right? So starting with pod security policies, then looking at workload security, best practices, and then looking at other policies either to mutate or generate configurations like for multi-tenancy. So there's maybe about 6 or 7 categories that are important,
Okay.
and systems that build on top of Kyverno, like different commercial systems will have like compliance standards, things like that, which
Okay.
will guide with this, right? But what we do within the Kyverno project is again have sample policies, and it's starting again like the guideline would be, if I had to sort of design this for my own platform, I would start with pod security, then go with workload security, multi-tenancy, maybe RBAC best practices as the next thing, and then at some point getting to software supply chain security, like making sure images are signed, you have the right attestations, things like that becomes critical too.
So slowly and incrementally, and maybe leaning on community best practices and some pre-made rules, sounds
Absolutely.
like.
And then as you're adding other things to your cluster, right? If you're like Istio, look at Istio best practices, right? If you're adding things like, again, Kada, or you're running Kubre for AI ML, or Kubeflow, all of these, there's policies for all of these, right? And it's just about how you want folks to be using your system, what things you want to automate, etc., right? So, um, but yes, there is a one interesting thing we've heard about Kyverno is, let's say, prior to Kyverno, if somebody were using other tools, they might have a handful of policies that perhaps came with like a vendor tool or was, that they had installed. But as soon as they start using Kyverno, because it's easy to write policies and manage policy as code, they usually we see it's not uncommon to see like 50, 60, or even in some case over 100 policies get created and managed within clusters.
We have a question from Sayan. There could be multiple use cases for such policies as we implement more policies. So, how do you keep them from conflicting?
So this is where the as code part becomes important, right?
The
So of course,
testability, yeah.
yes. So you want to make sure that, of course, if you have duplicate policies trying to do the same thing, you're deduping that, catching that, and validating the behaviors. So testing is very critical, and making sure that policies can be written and you follow code review, other best practices for those as well.
Is there a way to clean? What if a policy doesn't get used? Like, is there cleanup, or would it
Yes.
detect a duplicate or something? Yeah.
So if a policy is not enforced itself, yes. So there are several ways you can now validate. So Kyverno also has policy reports which run in cluster.
Mm.
There's metrics from the policy engine, so you can see which policies are getting used, how frequently they're called, what their latency is. So lots of different things you could do. So
Can you see if there's one just failing everything? Like you wrote a bad one and it's blocking a lot of stuff.
it happens, yes. So you can see, and of course you're going to get angry users. So you will
You
see
don't need
that,
a tool to tell you.
right? Yeah, usually if Kyverno is not behaving, for whatever reason, whether it's the policy or some other misconfiguration, or any admission controller, because it's in the critical path, you would know from your users quite early, right?
We have another question that I think is a good
Yeah.
one. They're all good questions. Is there an easy way to determine the policies and rules affecting a particular resource?
Yes. So again, with Kyverno, what you can do, and I'll show this, is once you run a workload or a resource, it will show you which policies apply to it, like both through events as well as, again, depending on the level of metrics you configure, you can check that on the resource itself. Also, another thing I want to kind of show, which is pretty cool, and how this again work fits into things like Argo CD. So I'm just going to run a workload now, which is actually compliant, right? So previously we ran a workload which was non-compliant. If I run this now, and I ran this as this user, Ned, just to show, if I kind of do this again as Nancy, the other user I have configured on this cluster, it should say, cannot get these resources in this namespace, so can't really run that, right? So now if we, going back to the question, if we look at pods here, let's just make sure that they're running. And if we go back and look at, this namespace resource, and we'll refresh and think again, what we should start seeing also on other resources within, these applications, is policy reports show up. And I'll just also deploy one more um, application as a different user, right? So this, I'm deploying a BusyBox app. It's going to create its own namespace, and I'm just going to do this again like we did last time through a PR, right? So we'll commit. This time, instead of just requesting a namespace, I'm going to request that an application be run. And if I push that, now it should be in my Git repo. So let's go and refresh this. This should show BusyBox is being deployed on my shared cluster. And this was for a different user, again, based on multi-tenancy rules. And now if you go back to my application list, I should see that there's also, on my shared cluster, BusyBox is here. And notice there's more resources here. And as BusyBox comes up, we'll also see in a few minutes, we should see a policy report start showing up, right? But if you go back to my cluster, if I do policy reports -A, right now I don't have any which showed up. But as soon as those kick in, what we'll see is different reports. Let me check on my main cluster if I have anything there, which will be visible. And a report is just also another resource within Kubernetes. So you can get it through kubectl, you can get it through other mechanisms as well.
Is the user who made the resource the one who has access to the policy report?
Yes. So here, and that's very important, right? That they are able to see. So by the way, now the policy report just showed up. So if I go over here, I can see now which policies got applied to my workload and what the score is. I'm expecting, because everything ran, a pass here, right? Because if we had policies in enforce mode. So if it failed, I would see, some failures here. I would know what
Will
those
you
are.
zoom in on that if you
Sure.
thank you.
Let's make this
Yeah,
bigger.
awesome. Cool.
So in this, by the way, this report format is something from the policy working group. It originated with Kyverno, but then it kind of became a broader use case where any other tool, any other scanner can also report things in the same format. And there's, we're
Mm-hmm.
working with different SIGs to try and make this a standard even within Kubernetes, so that it's a common API for reporting, right? But it's showing you that it applied, and for compliance, this is important to collect this data, that pod security standards were applied, and here's the rule that was applied, and here's the result of the rule, right? So for each one of these, we would have results pass or fail, along with some of the other details, and then you get a summary score. Now, of course, there's tools which can do all of this graphically and show you nice reports, but you can also get this, just directly, I guess, in cluster, or through any kubectl or any other tool, right? It's kind of nice. It just works with Argo CD, and you can see it here just because everything's a Kubernetes resource here. Yeah, so just to kind of quickly recap what we did so far, right, is we created a shared cluster, registered it with Argo CD, that triggered some workflows. which automatically ran Kyverno on that shared cluster. And now we enabled self-service, on that cluster, both for creating just namespaces, which with multi-tenancy policies in place, only the right user could access the right namespace. And then we were able to deploy applications just by, very simple constructs. So if I'm a development team, all I need to do is point to where my application artifacts are stored, in which repository, and then I can deploy either good or bad applications. And one final demo, what we'll do is if I change this to I have not good bad, but bad app. Uh, well, most of us are partly good, partly bad. But yeah, so let's see what happens here, right? So let's switch apps, and we'll push this back to Git, which Argo CD again. We have the application which got created, which should be watching that. So now if we go back and we'll start with oops, a bit too small. So yeah, there. I want to go to my to the right application, which is watching um, my YAMLs, right? And if I refresh this, what it should do is it'll try to deploy this BusyBox application. And if I go to the BusyBox application, what it'll say is it's out of sync because something's failing here, right? And if we go in here, we also see the errors coming back from Kyverno, which are saying, hey, something failed. Your container has capabilities which are not allowed. There's privilege escalation possibilities. Don't do that, right? I can't allow that on a shared cluster because of the security implications, and it just got blocked right away, right? So um, this is not as good as ideally, and through Kyverno policies, you can even apply this in the CI pipeline. But here, at least if developers have access to Argo CD, it's very clear what failed. Now they obviously have to remediate these issues.
So, as the author of the policy, it's your job to give the clear error message, so
Correct.
your user knows what's going on. Okay.
Correct. Or even give some samples which are I guess here we had two kinds of applications. We had the pod which was misconfigured, and then we had a better sample which has the right configuration, right? So if we go into sample apps, so a good application would in this case the deployment has the security context, has things like resource requests and limits, which if you go to the bad app, it's basically something you would find off the internet or in most demo scripts, you will see a pod like this, which doesn't have any of that configuration, right? Now, again, with Kyverno policies, you could inject some of that, but your pod has to be configured. Your image has to be built to allow things like, non-root users. So there's a few other best practices that come into play there as well.
When you inject things into a pod, like you mutate a pod that's coming through, does that get captured in your policy as code, or is that changing it at runtime in a more imperative way?
So the policy is declared to say what to mutate, right? So I'll go to an example
Okay.
policy here.
Uh
Uh,
huh.
so if you recall, one thing I said is when a developer requested an application, I didn't want them to specify a lot of details. I just want them to
Mm-hmm.
focus on which Git repo and what to basically, how to load the manifest from that Git repo, right? But in Arco
Mm-hmm.
CD, there's many other details like the patch, like the things like how you want finalizers to work. Like so, for
Mm-hmm.
one cool thing about this demo, and we'll do that next, is if I now delete this, I want everything to be cleaned up, right?
Mm-hmm.
Without this finalizer config and without some other things like tracking instances of the namespace correctly, that wouldn't happen automatically. So there's a lot of then manual tasks like, so this policy is generating all of that and mutating the application. So going from like what the developer requested, which would be something, these few lines, right? So here I'm requesting a sample application stored in this Git repo. I'm setting an owner label, which by the way, the policy enforces. There's an owner label. But now if I look at, in, let's say, if we switch back to the Argo CD cluster and look at the application here, and let's look at, let's say shared test as one of the application, there's a lot of other things which were automatically injected by the policy. So it is still declarative because the policy is saying what to inject, but then
Okay.
that action gets performed again in the API server. Like, even by the way, if you notice, we didn't specify the address, right? And that was the reason why I had that config map. Developers shouldn't need to know or care what the address of my Kubernetes cluster is. I might switch this, I might change the clusters or add a new cluster. All they're saying is, I want a namespace called test and give me access to it.
What if I'm a developer who's deploying an app and I do the bare, simple, easy stuff? And then there's some guardrails I can't see, and the guardrails put like a limit on the resources my app can use, and my app needs more resources than those limits I couldn't see. What happens? Do I get an error message that helps me understand what's happening, or is that a black box for me?
Yes, no, you will get an error message, so it'll say your quota got exceeded, and you
Okay.
can then request more, quota, more resources, and then if you, based on again if that's approved through your GitOps system or through Argo CD, then those resources, then you should be able to configure and kind of move on with next steps for your application. But yes,
Okay.
and
So
it
I
is
can see
important.
what's failing even though I can't see the policy when I'm creating them.
That's correct.
Okay, cool. I fear I'm asking you so many questions. You're not going to get all the way through your demo, so I'm going to zip it so you can
No,
get
that's
through.
perfectly fine. So just last step, what we'll do now is we'll just clean up, right? So
Okay.
I commented out both applications, so now we're saying, hey, there should be nothing, that we have. So if we go back to Argo CD, so notice, by the way, this finally gave up and said, hey, there's errors because of, again, the validation checks. But if we go back here and now if we refresh our apps, what we should see, oops, let's select all and refresh, is that the applications now, things like, which we no longer need on that cluster will get automatically cleaned up, including the namespaces, everything, right? So it's important, and it's waiting for, like the namespace to get deleted, but we should be back to our 4 apps that we started with as soon as we registered that cluster. So again, a quick, tour of how to build maybe a lightweight platform just using Argo CD and Kyverno and automating everything required for self-service namespaces as well as applications.
So what I like about it, it's automating self-service, but it's also providing like a nice simple interface for the developer to get what they need and not worry about the implementation details.
That's right. Yeah, and with
So
a little bit more platform engineering here, you could just, your developers really need to use Git and that's it, right? They don't need anything else because you can bake in some of these, policy reports, things like that, all into the Git pipelines, which makes it even easier.
amazing. Is there anything you'd like to add in conclusion or where people, I'll put up the Kyverno link, where people can go to learn more about policy as code in general?
Yes, so certainly, so this repo is available, it's public. So take a look at that. Would love to hear feedback. I think there will be so there are things we are discussing in the policy working group and in other groups about publishing a little bit more information on some of this, on also on how these systems within the CNCF, like you have great projects, how do you compose platforms out of that, right? So that I think stay tuned. There'll be more information and other things coming on that.
Super cool. I'm going to get to the ending script. Thanks everyone today for joining today's episode of Cloud Native Live. It's great to have you here, Jim, teaching us about Cloud Native Policy as Code with Kyverno. I've loved too the interaction and questions from y'all in chat. I appreciate you very much. And I also appreciate those of you who watch this recording. So here at Cloud Native Live, we'll bring you the latest Cloud Native code on Tuesdays and or Wednesdays at noon US Eastern. I believe the next one is next Tuesday. So thanks for joining us today, and I'll see you soon. Thank you. Thanks so much, Jim, for sharing your time and expertise.